Good morning, everybody. If you are seeing this, you are here on Tuesday, January the 30th. Mr. Nickerson is off to my right, probably here. Hello, Mr. Nickerson. Thank you for being here. I appreciate you subbing in our room. The kids always love you, and I love having you. Today, we are going to be looking at factoring expressions, building on what we did yesterday. Today is our problem day, so 4-5 problems. So students in their table of contents here can go ahead and add 13024. We got to make that a little smaller or else it won't fit in our box for you guys. You can go problems 4-6, and we're going to have 4, maybe 5, but you can go ahead and leave that blank today because we will catch that up when I get back on Friday. Okay. So again, lessons, 4-5, not 4-6. 4-6 is going to be later this week. Okay. So again, updating for 4-5. Okay. So what is factoring? Remember, when we talked about factoring yesterday, we talked about 3 main ideas of factoring. We talked about factoring numbers, finding numbers that are divisible by each of your 3 terms and dividing them out. And remember, you may not know the greatest common factor, your GCF, right away. So you may have to divide by our 2-3-5 rule, right? Are the numbers all even? Can I divide 2 out? Are the numbers all ending in 5 and 0? Can I divide 5 and 0 out? Are the numbers ending, are they 3 numbers, numbers that are divisible by 3? Can I divide by 3 in those situations? So we want to factor out the numbers in that session, okay? We talked about factoring out variables. We talked about factoring out variables, where if you have variables, you're just yanking those suckers out there and then rewriting your expression once you've had them removed, okay? We talked about factoring out negatives, where we only factor out when all of our terms are negative. And if we do that, everything inside becomes positive, and the outside just has a negative sign out there, okay? Sometimes we might be doing more than just one item, right? We might have an expression like, 3x plus 6xy, where we might have to factor out a 3, but also factor out an x, okay? So when you look at your finished inside expression, don't forget that you might end up having something else to be factored out. Just like if you notice that 2 numbers are even, 20 and 40, for instance, if you factor a 2 out, it's still going to be 10 and 20. You're still going to have more numbers to factor out. So don't just assume because you factored one thing out that you're finished. You may still have more factoring out to be done, okay? So again, we're going to go over our problems here today. We're going to be talking about their... Okay, hold on. Let me look at my setup here. We're going to be looking at these problems, much like when I'm there. I'm going to give you the problem. I'm going to give you some reminders. At that point, Mr. Nickerson is going to go ahead and pause the video. I'll let you work. Give you 3 or 4 or 5 minutes, maybe to work through those. And then once everybody is ready, we'll come back and I'll walk you through it. And again, there won't be any stamps today because I'm not there, but once we come back, we can look and we can update our stamps. So again, I don't care if you get it right. I want everybody to make an effort to try to factor them and try and see if they can get the solutions correct. And if you do, that's great. And if not, make some edits as I go through it and figure out what mistakes you might have made and why you made them. And hopefully you won't make those mistakes in the past. Remember, we're either getting a correct answer or we're figuring out why and learning on how better to do that the next time, okay? So let's start. Let's look at our problems, okay? Let's pull up our problems 4-5. So here's our first one. Okay, we're going to be factoring this expression. So you'll notice we have 2 terms that are not like terms. We don't have any variables being factored. So we are simply factoring numbers out here. And don't forget, when you factor out, okay, that's important to remember. When you factor out, remember, we're doing the opposite of distribution. Distribution was removing parentheses, so factoring is creating parentheses. So you need to have a parentheses expression, but you also need to have things that are out front of your expression. That's the biggest, most common mistake that I see made is when people factor things out, they have the things that they factored, but they don't have the things that they factored out outside the parentheses. They just give me whatever is left inside, which is not an equivalent solution, remember, because we're creating parentheses. Okay, so let me pull that back up. So Mr. Nickerson, we go ahead and pause and give the kids a couple minutes, and we will come back and go over the solution for this guy. Okay, guys, welcome back. Hopefully you work through this. We're going to go ahead and work through this guy here. Let's see. So we can notice that our, let me bring myself here. There we go. Okay. We can notice that we have our numbers that can be factored here as ending in 5. So it looks like 5 can be factored out. Okay. So I'm going to look at here. Let's pull that up once more, make sure we get it right. 45a plus 25. Okay. Okay, so we are going to go ahead and we're going to have 45a plus 25. Okay, and as you can see, we have two numbers that both end in 5. So I'm going to go ahead and I'm going to pull 5 out front. And I'm going to divide each of these terms by 5. So 45 divided by 5, I get 9, and that's my A term. And I divide 25 by 5, and I get 5. And as I can see, 9 and 5, no common factors. This is your solution. And again, if we want to check it, we can distribute these back in, and we would get 45A plus 25 if we wanted to check them. Okay, so this is your solution on number 1. Again, if you have questions and comments, you can pause the video now and ask and work through those, but that's okay. Okay, number 2. Here's number 2. Okay, notice we have some expressions going on, or some variables happening here. We also have some numbers. Okay, I'm going to go ahead and pause the video, and we will come back and work through number 2. All right, let's have a look here at number 2. Okay, we can go ahead and move down. And we have number 2 here. We can see the first thing we need to pull out, we can already see is a variable. Okay, I'm going to pull a variable out right away. Okay, I'm left with 15 here minus 6y. And I'm going to go ahead and do my 2-mark method because I don't want to be stuck with some weird subtraction thing there. Now, when I look at this, no y can be pulled out, but I do notice my 6 and my 15 are both divisible by 3. Okay, so I'm going to go ahead and I'm going to pull 3 out as well. So I'm going to take 15 and divide it by 3, and I'll get 5, and plus a negative, and 6 divided by 3 would be 2. So we would end up with the expression 3x is multiplied by the quantity 5 plus negative 2y. Okay, and these have no common factors, so I'm done factoring. Okay, and again, if I wanted to check it, I could multiply by both of these pieces. I could do the 3 and get 15 plus negative 6y, and if I needed to include my x in there, x, and I get my original solution. Okay, so this is your factored one for number 2. Okay, so number 1 here and number 2. Okay, all right, awesome. Okay, all right, let's look at number 3. So this is a little bit longer one, okay, but we notice no common variables. So we know that the numbers we're going to be factoring out are just that. We're just going to be factoring out numbers. Okay, so you can go ahead and pause the video, and we'll go ahead and work through number 3. All right, so we're back, and we have number 3 to work through here. Okay, we notice that we have no variables that need to be pulled out. Okay, and so we really just need to focus on the numbers. And we notice they're not all even, so it can't be 2. And we notice, hopefully, that 3 is a factor of all these numbers. Okay, so I'm going to take 3 and I'm going to pull 3 out, and then I'm going to divide each term by 3. So 18 divided by 3 is 6. That's our x value. 12 divided by 3 is 4, that's y, and 39 divided by 3 would be 13. And we notice 13 is a prime number, so it means we can't go any farther than this. So our simplified factored expression is this guy right here, 3 times the quantity 6x plus 4y plus 13. Okay. And again, we could multiply these back in and figure out, and we do get the same solution if we do that. Okay, and this is number 3. Okay. All right, let's keep rolling here. Okay, hopefully you're getting some of these solutions. Okay, here's number 5. So number 5 is just kind of a review. Okay, remember what the idea of like terms is. So I want you to go ahead and take a minute and see if you can jot down which of these would be considered expressions that have like terms in them, where if I simplified them, I would get one term as my solution. Okay, go ahead and take a second on that one. All right, we're back. So let's look at this first one. All these terms look like m terms, so this would be a good expression with only like terms. Okay, our second one, we can already see an x and a y. This one is no good. Over here, again, we have all t terms, so this would be good. So this third one over here is good. This one down here, now we have two m's, but one is mn. Remember, they have to be exactly the same to be like terms, so this one is no good. This 9xy and 6xy, those are exactly the same, xy. Okay, so that is good. And this one down here, we have a constant, we have a 9p. So upper left, upper right, bottom middle, all like terms. Okay, and if you have time, we have one more question today. If you don't get to it, that's okay. Okay, here's number 5, our final factoring of our expression. So if you want to pause that, work through it if you have time, and I'll be right back with your solution. Okay, so let's have a look at it here. We got 20 minus 110x. Let's go ahead and have a look at it here. Okay, so we have 20 minus 110x. We notice they are both ending in 0. Okay, so I'm going to go ahead and I'm going to factor out 10. Okay, so 20 divided by 10 is 2. 110 divided by 10 is 11. Okay, and it looks like we have a prime number here, so it looks like we're done. Okay, now say maybe you didn't notice it was 10. Maybe you noticed they're both even, so we factor 2 out instead. We get 10 minus 55x, because we divide these both by 2. 20 divided by 2 is 10, and 110 divided by 2 is 55x. And then hopefully we notice, hey, these are both divisible by 5. This ends in 0, this ends in 5. So we put this guy out here, and we get 2 minus 11x. And of course, these make 10. Okay, so we end up in the same place here, no matter how we factor them. Okay, so that one's, I kind of crossed over it there, but this is your solution. You also could have gone plus a negative, and that's okay. You could also write it in terms of like this, negative 11x plus 2, right? Your commutative property of addition tells you that that doesn't make any difference once we've used the 2-mark method. Okay. There we go. So hopefully you did some good work today. Hopefully you got in some extra problems, some extra work. We'll be coming back looking at adding expressions tomorrow. It's going to be some really similar practice to what we did in Unit 1, adding and subtracting positives and negatives and things like that and all that, that tomfoolery. So hopefully you feel well versed in that stuff. And we'll be back with you guys on Wednesday. So have a great rest of your afternoon. Mr. Barrage out.